Hello sir, my name is Raghavendra C. My branch is mechanical engineering. Topic name is earthing and its types. Earth, earthing and its types. What is earthing? Earthing is nothing but is a process of connecting the non-current carrying metallic parts of electrical equipments to the Earth's general mass. Second point, it creates a low resistance path for fault currents to flow safely into the ground, preventing electric shocks and equipment damage. First point, connect metallic bodies to the earth. Second point, ensures immediate discharge of electrical energy. Third point, maintains potential of equipments at zero. This is the ray diagram of the earthing. Different types of earthing. First point, human safety. Second point, equipment protection. Third point, voltage stability. Different types of earthing system. First point, earth electrode. A metallic rod, pipe, plate or mat buried deep in the soil to make a low resistance electrical connection, earth with connection. Second point, main earthing lead. The wire or strip that connects the main distribution board to the earth electrode, usually made of Gi. Gi means galvanic iron or copper. Third point, earth continuity conductor. The wire that connects the metallic parts of electrical installations like conductor casing to the electric earthing lead. Fourth point, earthing pit. The chamber built about electrode connection. The facility maintains watering and test or earth resistance. Types of earthing. First point, plate earthing. In this method, a copper of galvanic iron plate is buried vertically in an earth pit at depth of at least 3 meters. First point, plate size. Typically 60 centimeters into 60 centimeters. Second point, construction. Layers of charcoal and salt are placed around the plate to return moisturizer and improve conductivity. Third point, usage. Common in power stations and transmissions lines where high current carrying capacity is needed. This is the ray diagram of the plant type earthing. Second point, pipe earthing. Pipe earthing is nothing but the most economical and widely used method for domestic installations. First point, electrode. A, a performed galvanic iron pipe 38 millimeters diameter is driven vertically into the ground. Second point, watering. A funnel is attached to the top to pour water directly into the pipe. Keep the surrounding soil moist. Third point, mechanism. Performances allow water to seep out, reducing soil resistance efficiency. This is the ray diagram of pipe earthing. Third point, rod earthing. Similar to pipe earthing but uses a solid rod instead of a hollow pipe. It is often used to areas with sandy soil. First point, electrode. A soil copper rod or copper bonded steel rod. Second point, installation. Drive manually mechanical deep into the ground. Third point, ground. Easy to install and cost effective, highly durable due to copper coating. there are there are this is the ray diagram of rod earthing. Fourth, steep or wire earthing, used to primarily in the rocky soil areas where excavation for deep pits is difficult or expensive. First point, method. Steep electrodes are buried in a horizontal trenches at a depth of about 0.5 meters. Configuration can be lit in the straight lines or radical patterns. Maximized contact area. Third point, advantage. Efficient for transmission towers and rocky terrains. This is the ray diagram of steep or wire earthing. Last one and final one, factors affecting earth resistance. The resistance of earthing depends on the resistance of the earth pit, which should be as low possible. First one, soil condition. Rocky soil has high resistance. Clay loam has low resistance. Second point, moisture content. High moisture reduces resistance significantly. Third point, temperature. Resistance increases as temperature drops. Soil has very high resistance. Fourth point, salt content. Adding salt or charcoal reduces resistance. Fifth point and last point, electrode depth.